Hi, my name is Tot Darden. We want to thank you for purchasing this video, which covers the brazing procedures for the class that you're about to take. It's our EMGS ASSE 6010 class, which is in compliance with the ASSE 6010 standard. In this video, you're going to see the procedures that are necessary to complete a coupon in both the horizontal and the vertical position that will pass inspection and allow you to become credentialed as a medical gas certified installer. If you have any questions after watching this video, we want to encourage you to contact us. You can do so by either phone. Our phone number is 770-459-5920, or you can send an email, and my email address is tdarden@emgsi.com. That's tdarden@emgsi.com. Feel free to contact us with any questions or concerns that you have. We'll be happy to answer whatever questions we can. Thank you. In preparation for the brazing, you need to cut the 1.5-inch copper into two pieces. One piece that's 7 inches long, another piece that's 5 inches long. The reason for the dimensions is so that it will fit properly in the brazing jig. When it's put together with the coupling, the long end of the copper will go against the brazing jig. The short end will be out towards the tip to give you more room to work to braze the coupling. You need to be sure that the two pieces of copper are type L, N is not acceptable, and that the coupling is a ring style coupling, not a dimple stop and not a slip coupling. Each piece of the copper that's going into the coupling needs to be deburred with a deburring tool. It needs to be a deburring tool with a swivel head on it. You will take the inside lip of the copper off in a corkscrew fashion like this, so that there's no lip when it goes into the coupling. Each end of the copper needs to be cleaned with a Scotch-Brite pad to ensure that you've got a clean surface to braze on. Once you get both of the ends clean, you want to be sure that you put it together with about a 1/16 inch of gap in between the two edges of the copper. What this will allow you to do is, when you're brazing the tubing, the amount of copper that you're heating up on this side is going to be two thicknesses as well as on the other side, but in the middle, if you've got that 1/16 of an inch gap, it will allow a greater transmission of heat in the center section. Now when the rod melts, it's going to flow to the hottest point. So if you've got more heat in the middle, it will allow the rod to travel towards the middle and give you full penetration on the joint. The gap that you have in the middle is important to try and maintain. You're going to place the pieces into the jig as an assembly that's 1 foot long. You'll start a purge going through the jig at about 60 cubic feet an hour. Be sure that you can feel the purge coming out on the opposite end of the jig. Remember that you're going to be doing two joints, one in the horizontal position, another joint in the vertical position. When you do the vertical braze, it's going to be done from the bottom up. The jig will then allow you to rotate it 180 degrees to the other side, and the second side will also be done from the bottom up. Once you finish the joint, horizontal or vertical, you want to remove it from the jig. On the horizontal joint, cool it off, and then you're going to mark it in 3 places on the top. You need to be able to determine where the top is. That can be done by looking at the bottom, and if you have a small drip on the bottom, then 180 degrees from wherever that drip is would be the top. In any case, once you determine where the top is, make 3 marks with a Sharpie, one on the longer piece of copper, one in the middle of the coupling, and another on the shorter piece of copper. The reason for the 3 marks is because we're going to have to split this entire assembly longitudinally at a 45-degree angle from top dead center. So we've got to know where the top is on the horizontal. Also, we're going to trim the section, the 1-foot section of coupon, so that it's 6 inches long. 6 inches is what we're going to send to the lab for analysis. So we're going to want to trim 3 inches off of this end and 3 inches off of this end to ensure that we have a 6-inch long section to send in. On the vertical coupon, it doesn't matter where we split it. Keep in mind that when we're splitting it, we're going to try and maintain 2 equal halves. If it's not exactly equal, that's okay, but we want to try and split it in 2 equal halves. Each half is then going to be flattened out. There'll be a tension test performed to see if it comes apart, and we're going to be looking for full penetration all the way to the middle of the coupon. Okay, let's talk about reasons that the coupon will not pass the brazing test. On the horizontal joint, when you start to braze, you need to be sure that you start on the bottom of the coupon and then work your way up along one side, come on the other side and work your way up on this side. You want to go from bottom to top. If you try to start feeding the rod on the top and progress toward the bottom, gravity will cause the melted rod to flow at an angle down, and you'll wind up having a void that you'll have to go back and try and move the rod through to get full penetration all the way to the middle. So you want to be sure that you start on the bottom and work your way up. If you can imagine the joint as a pie and kind of divide it up like pieces of a pie, you work on one piece, get full penetration on that piece, move up like the tick of a clock to another piece, get full penetration on that piece, and so on, all the way to the top. Come up this side and then do the other side. Another reason that people have trouble passing the brazing test is because there is an improper amount of heat to cause the melted rod to travel towards the center. In other words, the edge is hotter than the middle. You need to be at least 900 to 1,000 degrees to melt the rod, but you need to be hotter than that in order to cause the rod to flow to the middle. So the rod has to be liquefied on the edge, so you would be 900 to 1,000 degrees here, but you're going to want to be in the 11 to 1,200 degree range in the middle, so that the hotter portion of the coupling would cause the rod to draw up towards the middle. When you heat the coupling, it should be cherry red, and you should heat the coupling up completely before you ever touch a rod to it. In other words, once you assemble the coupling and you get it in the jig, get the coupling red hot with your torch before you ever touch a rod to it. Once it's red hot, the entire coupling is red hot, then you can focus the heat on one portion of the coupling and start feeding the rod. Another problem people sometimes have is the position of the rod. Usually you need to hold the rod at about a 30-degree angle to the edge of the coupling and feed it in. Some people will wipe the rod, and I'm not saying that you can't do it that way, but if you do it that way, if you wipe the rod, you're going to create a little puddle of liquid rod, and you'll need to move that with the heat or the torch. You can do that with a circular pattern and kind of move it towards the middle once it becomes a melted puddle. It's possible to do it that way, but the way that most people will do it is to touch the rod to the edge of the coupling and feed the rod in as you're moving it with the torch with your other hand. If there's a lot of rod material accumulating on the outside edges, that means that there's more heat on the outside than there is towards the middle. If you move your heat more towards the middle and keep your rod moving, that will correct that problem. You need to be careful that you don't heat the coupling up too much, because if you get it too hot, you can blow a hole in it. We're going to be using A32 tips with an air acetylene tank, and it will get the coupling plenty hot enough to melt it or blow a hole in it, and of course if you do that, that's an automatic failure. Another problem people sometimes have is not enough rod. You don't need to be conservative with your rod for the purpose of passing this test. It's going to take 1.5 to 2 rods to fill up both sides of the coupling. Don't be concerned if it takes more than that. It could take you 3 or 4 rods. Now that means that all the rod is not going inside the coupling if that's the case, but you do what you need to do in order to get the rod to move towards the center. And then the biggest reason that people fail this brazing test is an improper amount of time spent doing the coupling. You need to take your time. As I said earlier, heat the coupling up, get it cherry red before you ever touch the rod to it. Once you get it completely heated up, it's going to take you probably about 10 minutes to do the joint. Do not get in a hurry. Take your time. Work the coupling like pieces of a pie. The same thing on the vertical. You want to work it like pieces of a pie. Don't try to get the rod moved up partially, then go to the next section of the coupling and try and get it moved up partially. Get it moved up entirely on one section before you move the torch to another portion of the coupling. On both horizontal and vertical, work it like pieces of a pie or ticks of a clock. Notice that when you're heating the coupling up, you can see the rod traveling towards the middle. When you get it cherry red, there will be a silver outline of the rod moving towards the middle. You need to understand, though, that when you pull the torch away, the heat's going to be lost almost instantaneously. When that happens, copper oxide is going to form on the outside, black particulate, and you'll have to reheat it. The more you reheat it, the harder it's going to be to see that outline as it travels towards the middle, because there will be more particulate accumulating. So on the vertical joint, when you're doing that, the first side will probably be somewhat easier than the second side, because you're going to be heating up a piece of fresh copper. You can see the rod travel up. When you rotate it 180 degrees, this is already hot. You're going to have to heat it up again, but you can still see it. But the more you heat it up and the more rods you apply, the more difficult it's going to be to see the rod traveling up. That's why if you do it with 1.5 to 2 rods, it's going to make a much better joint. You can see what you're doing. You want to pay attention to the pin that holds the jig in position. To remove the pin, you push the blue button on the back side, remove the pin, and then you can rotate the jig 360 degrees. You want it in the up position for the vertical. Insert the pin back in, and then when you get ready to do the second side of the joint, pull the pin out, rotate it 180 degrees, and do the second side. In the horizontal position, you would of course leave it right here. When you put the coupon in the jig, you want to, of course, remove the wing nut, the spring cap, and cap assembly for the copper. Insert the coupling in with the long end toward the handle. This will give you more room to work when you're doing your braze. Put the cap back on and the wing nut. And when you tighten the wing nut up, you're going to want to be sure that you tighten it up enough to keep it in the jig, but not so tight that you reduce your gap, your 1/16 inch gap between the two edges of the copper that is inserted into the coupling. Once you get it tightened down, you may have to retighten it if it becomes hot and loose. Once you get it positioned, you want to turn your purge on. There's a valve here that will control the purge going into the tubing. Be sure you set your purge at somewhere between 60 and 80 cubic feet an hour. And then be sure that you feel the purge coming out the end of the cap, so that you know that you've got a positive purge there. It's possible for debris to accumulate in the jig and obstruct the purge. You want to be sure that you've got a good purge coming through before you start the braze. Now once you finish the braze, you're going to want to let the nitrogen continue to flow through until the joints had time to cool, usually 3 or 4 minutes. After that happens, you can remove it from the jig, the nut, the spring, the cap, and the coupon, cool them off in the bucket of water, and bring them to be cut. On the acetylene side, You want to be sure to maintain 15 pounds of settling pressure. Once you finish, and the joint has completely cooled off, be certain that you close the valve on the nitrogen purge rig after it's cooled, and then remove it. Of course, when you walk up to the purge rig, be sure that you turn the valve on, and don't forget to have it turned when you're brazing. We're going to now do a joint in the horizontal position. You can see the joint is set up in our jig. We're going to turn on the purge, and nitrogen is going to be flowing through the coupon to displace all the air so we don't have any oxidation. We're now going to strike the torch, and we'll go through the brazing process in the horizontal position. Now notice that before he ever touches the rod to the coupon, he's going to get the coupon very, very hot, cherry red, before the torch ever touches it. All right, the coupon is completely hot now, so he's touching the torch to it. Notice how he's starting in the bottom position with a little bit of melted rod. And once he gets a pool of rod melted, he can kind of work that with the torch and manipulate it, move it towards the center. You've got to keep the torch moving though, so that you don't blow a hole in the coupling. If you focus the heat too long in one place, there will be a deformation that takes place in the copper. You also want to try and lead the rod with the torch. In other words, the melted rod is going to flow to the hottest point, and it's going to follow where that heat is. So if you're leading the puddle with the heat of the torch, it will move it towards the middle. The edge has to be hot enough to melt the rod, but again, the heat has to be ahead of where the puddle is going. In other words, it's going to flow to the hottest point. Once the cup is full of rod, it is permissible to go back and try and distribute the melted rod that's there. That's what he's doing now. He's got plenty of rod in the coupling, so he's trying to distribute it, move it around, make sure that the entire coupling is covered all the way through. Want to be sure that you cap the outside edges of both sides of the joint as well, so there's no voids in it anywhere. Now, once you're finished with the brazed coupon, you need to let the nitrogen continue to flow to cool it off for 3 or 4 minutes. It won't be completely cool. We'll do the remainder of the cooling with water, but we want the initial cooling to take place with the nitrogen so that we don't have any oxidation on the inside of the joint. All right, now we're going to do a vertical joint. Remember that both sides of the vertical joint must be done in the upflow position. We're going to do the first side, then we're going to rotate the jig 180 degrees to do the second side. Once again, the coupling needs to be red hot before the rod is ever touched to the coupling. On the first side, when the brazing begins, you can see the rod material actually traveling up against the red background of the coupling. Now, the more it cools and heats up and cools, there's going to be copper oxide that forms on the outside of that coupling, and it's going to make it more difficult to see the travel of the rod going up towards the middle. So the second side is going to be more difficult to see than the first side is. But once again, you want to try and move the melted rod up with the heat of the torch. it's going to travel towards the hottest point of that coupling. Now the first side's done. We're rotating the entire coupling 180 degrees. We're going to do the second side. Notice that we're doing it while the coupling is still hot. We're obviously going to have to reheat it up, but you want to do this as quickly as possible so to try to maintain the heat. This is the completed horizontal coupon. Now before we started this coupon, we actually made a mark on where the top side of the coupon was. You can see 180 degrees from that mark, there's a little bit of drip, so we've actually got a 2-point confirmation of where our top is. Since we have to cut the coupon on the horizontal at a 45-degree angle from top dead center, we're going to make 3 marks along where the top is. So there's our mark. We're going to come on this piece, we're going to make a mark here, a mark in the middle, and a mark on the longer piece. Now when we split this coupon, we're going to do it at a 45-degree angle from top dead center into 2 halves. When we cut this coupon, it's got to be exactly 6 inches long. So we're going to take a ruler and we're going to measure 3 inches out from either side of the center. We're going to make our marks here so that we know ultimately that's how long the completed coupon is going to be that we send in. We're going to cut the short end off first. Then we're going to split it at that 45-degree angle from top dead center. And you can see we have 2 equal halves. We're going to flatten the 2 halves that we have cut partially with a hammer. We're then going to finish the flattening process in our press by inserting it completely flattening it, and then we're going to do our bend tension test. Now, once we've done our bend tension test in one direction, we're going to take this coupon, we're going to flip it over, and we're going to bend it back the other way. Coupon is bent and then flattened back out. Once the tension test is done, we're going to look at it under a lighted magnification glass to see if we can find any voids. Now, this is an example of a coupon that passed. You can see the separation in the middle so that we got full penetration of the rod up toward the center. You can also see that we have no voids along either edge of the coupling. So in other words, there's no voids along this surface. There are no voids along this surface. We have penetration to the middle here, penetration to the middle here, and if we look at the outside edges, we have no void on this edge and no void on this edge. This is an example of a coupon that passed. This is an example of a joint that the rod was traveling all the way to the center on a portion of it on this edge right here. But you can see in the middle when we bent it that it didn't get all the way to the center. See the gap in the center, so this is a fail. We didn't have penetration all the way through. It came part of the way, but not all of the way. The same thing is true right here. This was a very good joint across this side right here and this side right here, but on the edge it folded back so we didn't have full penetration. Note the gap that we have in here between the 2 edges of the copper so that we can focus the heat in the middle and suck the rod up towards the middle. You want to be sure and maintain that gap. Here's another example of one, again, where this side looks good. The rod traveled all the way to the middle, but on this side we got it halfway on this portion of the coupling, but not on the edge. It separated when we bent it. And we're going to be doing a bend test, and we're going to be looking not only at these middle surfaces, but the side surfaces as well. This side, to ensure that we don't have any voids. We're going to be looking at the outer surfaces to be sure that there are no voids on the outside. So you want to be sure that you cap the edges, the outer edges of the coupling before it's sectioned. We want to thank you for watching this EMGS brazing procedure video. Hopefully it's been informational. Hopefully you've gleaned something from it that will be beneficial for you not only for passing the brazing test, but also as a medical gas installer in the field. We want to emphasize once again that if you have any questions or concerns in the future, you can feel free to contact us either by phone at 770-459-5920, or you can email me directly, Tot Darden. My email address is tdarden@emgsi.com. That's tdarden@emgsi.com. Please feel free to visit our website as well, www.emgsi.com. We want to thank you for your attention and your participation in our ASSE 6010 installer for medical gas program. Thank you.